Okay, hopefully this is what you're here for. You were just here for the cartoons. Okay, so this is a double session. Um, it's just one continuous set of slides. When I gave it last week, I ran out of time. So I will try and go a little bit faster at the beginning this time. And there's a little bit of audience participation coming up, so don't all fall asleep. I'm Adrian Cockcroft. I was previously with Netflix, and I was in Aarhus 2 years ago presenting about the Netflix architecture and open source and things. I didn't come last year. We sent, I think it was Ben Christensen who talked about reactive and RX Java and things. Ruslan Meschenberg would come and talk about the Netflix open source tools, but he couldn't leave. Probably something to do with launching Netflix in Germany, Austria, France, Belgium, Luxembourg, and Liechtenstein or something, which happened last week. I think they got a bit too busy. So I offered to give this. So this is an extended version of a talk that was originally given at the Amazon reInvent conference last fall, which is why the background is black, because that's the template that Amazon gave us. And I'm going to go through the different open source projects that Netflix has put up and try and explain what they are and how they fit together. And you'll sort of get some idea of the Netflix cloud native architecture from just looking at all these projects. And I can talk a bit about why they are the way they are and some of the non-obvious things. But this is all code that's on GitHub. All right. So to start with, I'm going to assume that you've started off when you're an architecture sort of Ruby on Rails running on a single Amazon zone. You've got a MySQL server, you've got a middle tier machine, maybe a handful of front ends, and a handful of customers. Okay, so that's a typical starting point. We see this a lot. I know I work for a venture capital company, and we see lots of companies that have just done, they've got the first product out, and they're starting to get some revenue, and they come and they say, okay, we've got customers. Look, we have 10 customers and we have revenue, and give us some more money. And so we give them some more money. You get funded. And now they say, okay, now you're going to get more developers, more customers. You need it to be more highly available. You need to be globally distributed instead of in one place. And your old architecture doesn't work anymore because your growth is now growing exponentially. So one of the things I do for Battery Ventures is I work with companies that are going through this problem, and I help them as sort of a consulting cloud architect, scalability architect, that kind of thing. So what they'd like it to look like is this, and this is a sort of rough version of the way the Netflix architecture works. You have lots of different customers in lots of different regions. They come into a regional load balancer. They get routed to the different places, and then you have these microservices in zones replicated in one region and then replicated across to another region, and in Netflix case using Cassandra to replicate everything underneath. So pretty much all of the data that moves cross-zone is moved there using Cassandra. You can do this also with React, which has similar functionality, but Netflix for various reasons has used Cassandra to do this. So that's a fairly different architecture from that. So how do we get there? Inside each of the availability zones, which you think of that as a data center, so that's Netflix runs actually out of 9 data centers every day, 3 on the East Coast and 3 on the West Coast of the US that run in parallel redundantly, so it can switch between them, and 1 in Europe, 1 set in Europe, which is Europe's something more like 10% of Netflix traffic, so it's a relatively smaller system. So within each zone, let me think, I've got lasers here. Yeah, there we go. Requests come in, and then because this is all based on microservices, there's lots of requests that go out, and then they hit all these things and bounce around, and it comes back, and then the home page gets returned. So that's for a single API call or a single request to the home page. And this is actually an old simplified diagram from about 3 years ago, because when I tried to update it, it was so complicated I couldn't draw it anymore. So yeah, you've got all these different services that you've put together, and you need to stitch them together and form it into this kind of architecture. So Netflix is a Apache licensed open source platform that does this, and you can download it, and quite a few people have. And I'm going to go through and ask you if you know any pieces of this platform and if any of you have used it. And I have a special prize. It looked originally like that, but some pieces got taken when I was in Copenhagen. And the most deserving people in the audience get laptop stickers. And this is the latest Netflix open source logo, the kind of the red on white one instead of the old crummy logo that Netflix had. So parts of this are available, and I think there are 5 stickers in total, 1 big one and 4 little ones. So if somebody wants a laptop sticker, you have to kind of show that you actually are interested or you know something. All right, so this is the beginning of the quiz. What do these do? What do we got here? Hystrix. Anyone know what Hystrix does? Was anyone here a year ago? Yeah, the circuit breaker code. Yeah, cool. Excellent. So that's actually what Ben Christensen was talking about last year. It's part of his talk, talking about circuit breakers. So Hystrix is a circuit breaker system. I'll talk about that later, but it's if you think about Michael Nygaard's book, Release It, there's a pattern in there called circuit breaker. It's a Java implementation of that. Simian Army. Yeah?
At least Chaos Monkey is something that disables machines and configuration in production systems.
Yeah.
Make the systems more resilient.
Yeah, so Simian Army includes all the different monkeys that Netflix has got. And the best way of thinking about that, if you think about a Unix operating system, there's a bunch of daemons that run around and do things within it. But we have monkeys in the cloud and you have daemons. It's a daemon anyway. Demon's a silly name as well. Okay, but we just got used to it because they've been using it for 40 years, right? So another 30 years it'll be common to call things monkeys if they run around autonomously and fix things in your cloud. So just think of them as the autonomous services that rummage around in the cloud and do administrative things, including the Chaos Monkey, which kills things for you to prove that you can survive having things die. Turbine, anyone know what that does? So there's a dash. It probably won't. It's really used with Hystrix. Hystrix is a circuit breaker for a single machine, and it has a console that you can view in a web browser. And if you need to aggregate across an entire tier of machines of the same type, then that's what Turbine does. It gathers them together. So it's a sort of a streaming MapReduce thing. All right. Well, I've got a whole page on each of these later on. Next, ICE. Anyone here use ICE? Anyone here use AWS? Would you like your bill to be smaller? Maybe. Okay, that's what ice is for. You put your bill on ice and it shrinks and gets cold, shrivels up. I'm not quite sure why it's called ice, except that it's one of the most pronounceable and spellable names in this thing. As you'll see, we have some very complicated names, but this is one of the easy ones. It's a dashboard for looking at all the costs. So it's an extremely sophisticated tool for monitoring your AWS billing, and it's what Netflix developed in order to manage Netflix's Amazon bill, which is one of the largest on AWS. So that's it's a good tool. Asgard. It's a Norse name. What is Asgard in Norse mythology? Do you remember? It's the home of the gods. So this is the console that's used to control the clouds, because we figured that that's where the gods would live. So it's the developer console that replaces the AWS console. We'll look at that later. Frigga is I'm not quite sure what Frigga is in mythology, but it's actually a subset of Asgard. If you want to interact with some of the objects that Asgard's managing programmatically, it's just a little helper library. Glisten is a Groovy-based domain-specific language, which is used for writing workflow applications. So there's a tool from AWS called SWF, Simple Workflow. It's a REST API for building workflows for things that must happen once and only once in a guaranteed manner in a very, very resilient way in a distributed system, which is actually a fairly hard problem to solve. It's actually quite a hard computer science problem to build a workflow engine. The basic guts of one is available on AWS as an API, and this is a Groovy-based DSL that makes it easy to use. And again, it's used by Asgard to sequence deployment operations around the world and things like that. All right, next. SDNX. Okay, we're on Greek mythology now. Anyone use this? Anybody here use Cassandra? Okay, that's probably why you're not using it. All right, so this is a Java client library for Cassandra, the Cassandra database. It's a very powerful, flexible library. We'll come up to why. Astyanax is the son of Hector, and Hector was the first Java client library for Cassandra was called Hector, has Cassandra's boyfriend. So a lot of Greek. Cast JMeter is a JMeter plugin for testing Cassandra. So if somebody's thinking about trying Cassandra and you're used to using JMeter, you download this and it's got all of the right hooks for just load testing Cassandra clusters to make sure everything's working right. Very simple. I think this was actually clickbait for QA engineers because we want people at Netflix that know how to use JMeter to load test things, and we were trying to hire people. And we said, where should we hire these people? Well, let's go on GitHub and see who's forked this project and give them a call. And then we go hire them. It's a trick. Because the whole GitHub site on Netflix is really just a big honeypot for developers. That's the best way of thinking about it. And that's the way you should think about your GitHub site. And it works really well. Anybody know what Curator is? It's a top-level Apache project. It's not even just a Netflix project now. It's a real Apache project. Part of the Hadoop HBase ecosystem. It's a library for making Zookeeper much easier to program from Java. Zookeeper has a fairly annoying API. It's kind of a pain in the neck to deal with. So this is a cleaned up layer that makes it much nicer for handling Zookeeper. So if you're using anything in the Java ecosystem, Java or Scala or whatever, you should probably be using Curator to talk to Zookeeper rather than talking to it directly yourself. It was so good that the HBase guys decided they wanted to rewrite HBase to use it. And so they forced, basically they said, please will you make it a top level project. So you have to give up your babies for adoption sometimes. So this is the one where Netflix no longer controls this project. And there were 2 committers from Netflix and 1 from outside. The primary guy that wrote this no longer works for Netflix. He decided he wanted to live in Panama in Central America. Netflix doesn't support remote working very well, so he now lives in Panama. And he still fixes bugs for us. We don't pay him. It's brilliant. So I encourage you to open source all your key software so that when the people that wrote it leave your company, they continue to write code for you. It's an excellent way of working. EV cache. People here use memcached? Yeah. So if you use memcached from Java, this is a library that wraps up that. And it's really used for it's used for coordinating multiple memcached across availability zones. So it gives you a replicated memcached. It doesn't claim to be consistent at all. So it's the eccentric volatile cache. It is sometimes somewhat consistent, but has no guarantees whatsoever. So it's just a volatile cache. Use it for session cache and time things out really quickly. Exhibitor is a system for managing curators and zookeepers. So apparently there's all these zoo-related things. So you have a curator of a zoo, and there's an exhibitor in a zoo. So if you're trying to manage a whole lot of zookeepers and keep them all running automatically, you need some automation to do that, and that's what exhibitor's for. Okay. So all the zoo-related ones are something to do with zookeeper. And then Priam. Anyone know who Priam is? Greek mythology again? This is a quiz, right? Okay, Priam was Cassandra's father, right? So this is what you use to look after Cassandra, do backups, make sure, no, you can't go out wearing that and come back by 10 o'clock kind of stuff, right? So think of a paternal kind of thing. So Priam is a Java Tomcat process that you run on a AWS instance. And that's the thing that comes up. Also on that instance is a copy of Cassandra, but it's not running to start with. Priam comes up and figures out what state everything's in. It will do backups, restores. It will bootstrap a Cassandra cluster from nothing into a running cluster in a few minutes. So you just start a whole lot of machines running Priam, and they will self-organize into a Cassandra cluster that you can write to immediately. It's trivial to create Cassandra clusters at Netflix. And all of the automation required to do that on AWS is done using Priam. So the base Cassandra code doesn't assume it's running in the cloud. It can run anywhere. So all the code that knew about AWS had to be in a separate place. That's what Priam is. If you ever built a service that has a database behind it and just to give REST access to a database, right? So what you want to do is you want to build a storage tier What was it? Storage tier as a service over HTTP. Stash, right? Stash with two A's. Storage tier as a service over HTTP. So it's a data access layer, a prototype. This particular implementation knows how to talk to MySQL and to Cassandra in the same code base. It has all the drivers for both. So you can actually use it as a part of trying to get off of MySQL. If you want to split some code off, you can put it in front of MySQL, start using HTTP to talk to it, and then you can actually plug Cassandra in and start using the same type of accesses. It also contains a bunch of Cassandra client-side patterns which make using Cassandra much easier, which we'll look at a bit later. All right, halfway through these. Archaeus, which sounds like a Greek god, but it's actually the Latin name for some kind of lizard, and I have no idea why we use that. It's a property management system. If you start off with sort of Apache properties and you keep tinkering with it and adding layers of complexity and trying to deal with all the problems you're going to have, that's what you end up with. So it's a fully distributed property management system for configuring large-scale systems. Look at more of that later. Anyone here use DNS? Hopefully. Anyone here like programming DNS? Anyone here tried to script and automate DNS? Did it work reliably for you? No. No, we spent 6 months beating our head against that problem. I think this is a DNS automation library. I think we debugged the DNS vendors solidly for 6 months, and at the end of it decided that none of them worked except Route 53. So AWS's DNS, you can automate it, you can script it, you can ask it to do anything, and it will reliably do the thing you asked it to do. Like you thought that all the other APIs were like that too? We were kind of naive. Turns out the others all break horribly if you try and ask them to do things more than one at a time and wait a while, and then one at a time and wait a while. So be very, very careful. It's a Java library, plus it's a command line script, and it's pluggable. And if you have other DNS vendors, we have OpenStack and Rackspace DNS support in there, and then there's a mock DNS, so you can actually do testing against it. So it's a very, very nice library. In fact, this is a beautiful piece of standalone code. Built into it is an HTTP client that's used to drive all the other vendors, and that client is actually Feign, which, these two were written by Adrian Cockcroft. You might have heard of JCloud, Cloud's library. Quite a lot of things are built on JClouds. He worked for Netflix for about 9 months, and mostly what he produced was these two things. Okay, so when you're creating microservices, you want to start with a basic microservice, right? And you want it to be just like a prototype with all the stuff already hooked up. So that's what carry-on is. It's an elementary particle for a microservice. You basically have it's a Tomcat server, or they're working on Netty-based servers for it as an upgrade. It has it's basically an HTTP client, HTTP server, base servlet with all of the bits and pieces that you need to instrument that, monitor it, and all the stuff. We'll get to that later, what it's got in it. But it's the thing you usually start with. And then when you want to make a call into a microservice, between microservices, you want to be clever about how you distribute your requests, and you want to be do load balancing in ways that are very robust, and that's what Ribbon is. So Ribbon is the client-side library for it's a wrapper around HTTP client, but it's much more sophisticated and aware of all of the other things. Okay, anyone have used any of those? No? Okay, Servo. This is, you use this for collecting data about a system. It's a little bit like, what's the thing called? Yammer metrics. Everyone use metrics? So we're actually looking at one point at merging it with metrics, but the APIs were just a little bit different, the use case a little bit different, so we didn't. We think we probably should have, but we required 2 egos to come into alignment, and it didn't work. Merging open source projects is a pain. Anyway, basically you can plug some mbeans and things into it. You can collect business metrics, and you can export them directly into AWS and use that to drive. Use the business metric to drive auto-scaling rules. So we'll look at that a bit more later. Now, who uses log4j from Java code or JVMs, right? What happens if you push too much logging information into it? You ever tried that? Your systems gradually lock up, and the logging system starts stealing all the threads from the things that we're trying to get work, and then your system actually collapses in a sort of a runaway snowballing effect of just too much logging causes additional logging, causes more it's resource starvation, and you can tip a machine over to the point where it can't do anything except be a sort of in this constipated logging state, where it can't do anything except try and log things, and it can't even log things anymore. So to get away from that, and because Netflix likes logging lots of data really, really, really fast, Blitz4j is built as a non-blocking front end to all of the Log4j kind of API. So it's has similar functionality for Log4j to Log4j, but it doesn't block. That's its basic reason for existing. And it uses a separate thread pool, so it doesn't steal your threads either. And now you can log 10 times as much stuff. People here use dependency injection as a problem. When you've got lots and lots of libraries, you have to assemble them all in the right order and make sure you initialize each of them once and in the right order. Big pain in the neck to figure out. We had this ad hoc way of doing it that got very messy. So at some point we decided to use Google Juice for that. Some of you may use Juice. And we wrapped a whole bunch of extra stuff around Juice, and that's what Governator is. So it's an extension to Google Juice, which lets you do dependency injection in a very standardized way. And the other components of NetflixOSS mostly use Governator to do that now. All right, what have we got to now? Edda. Edda's another Norse word. Does anyone? Okay, who speaks Norwegian, Viking, whatever? No, okay. I thought this would be the one place where you'd know. We have one vaguely Norwegian guy at Netflix for a while, and he named a whole bunch of things. It's the stories of the Norse gods. So, do you remember when every time a Malaysian airliner disappears in the sea, they go looking for that black box, right? And they're still looking for that particular black box. But when you find the black box after an aircraft crashes, it's got a full history of everything that happened to that plane in it, and you can figure out what happened, what was being said on the flight deck, what all the state of all the system was, right? Now, wouldn't it be cool if you had a black box for your data center and your applications and your cloud, right? That's what it is. It's an incredibly simple concept. It's a fairly simple application. It's a little Scala process, but you basically, the first thing you do when you start an Amazon account is you start a copy of Edda, and it records everything that ever happened in that account. And if you want to go back and look at what the state of it was in the past, then you can actually find out. Very powerful. Now, when you're building microservices, you have all these services, and they have to be able to find each other. So you have to have some kind of service registry where everyone says, hey, I'm here, and some way to find out where everybody is, right? So you can make calls between them. Netflix architecture uses direct calls between services. There's no message bus layer that's doing routing for you. So Eureka is the library is the service that basically builds a service registry, a distributed service registry, and very highly available. You could use Zookeeper or Consul or whatever to do this, but there are things that will take Zookeeper down that will not take this down. So it's not necessarily the cleanest, nicest piece of code. It's because it's one of the first things Netflix wrote, and it's been beaten on for a long time, but it's one of the most robust pieces of code. Because every time your service registry goes down, you go down. You go down really badly. So every time this has broken Netflix, we fixed it. Okay, Zul. Anyone know what Zul was? Where the name comes from? Ghostbusters. Yeah, we have a Ghostbusters fan. So Zul is the gatekeeper, I think, for Ghostbusters, or there's some monster that... Anyway, so it's an API proxy layer. You put it in front of all of your systems, and you create an API, sort of a set of API requests that map into whatever you want at the back. So if you have a whole lot of microservices and you want them to look like one unified API, like they were a single monolithic service, you put Zul in front, and it's a very thin programmable layer that routes and modifies traffic, so you can manipulate things. So it was used to replace what's it called? Apogee. Apogee have a product that's also an API proxy that does different things to this, but it was used to replace what previously we were using Apogee for. All right. Anyone here use JVM's garbage collection? How do you visualize your garbage collection? Hey, garbage collection visualization. There you go. It's a little standalone tool. You just feed your logs to it, and it will visualize what was going on and confuse you more, probably. I don't think there's only 2 people in the world I know who actually know how garbage collection works. One of them wrote it, and the other one is a friend of mine who was sharing an office with him for 5 years and who works at Netflix. Pytheas is a... Okay, so everyone has all of these machines, and then they end up building dashboards for their software, right? Everyone just ends up building dashboards, and it's a pain in the neck building dashboards. So somebody once, over a weekend at Netflix, decided to assemble together all the parts that everyone always used to build dashboards and put together a dashboard building framework built out of all of the other frameworks. So it's got Bootstrap and, I don't know, FreeMarker and things like that in it. It's just all of those, jQuery, whatever. It's all the stuff you would need to build a dashboard glued together into a sort of a framework where you insert a few bits of code in a few places and a big dashboard appears. It's got D3 in it and stuff like that. All right. Getting there. Aminator. Any clues? So the Netflix container been used for several years as an AMI, an Amazon machine image. So you have to, like if you've been playing with Docker recently, you have to build Docker containers, right? And then you ship the container off to somebody to run it or fire it up. So Aminator is the bakery that Netflix uses to take code and bake it into AMIs. So think of it as a very sort of early, crude prototype for what Docker has currently become. Netflix is now trying to figure out how to use Docker, whatever. All right, big data. People here play around with Hadoop? You got a big data people? No big data people. No one likes Hadoop here? What do you guys do all day? To find some technologies. All right. Aegisthus is the person in Greek mythology that killed Cassandra, which is why there's a sword there. And it's used to scrape data out of a dead Cassandra cluster and feed it into Hadoop so you can process it. Genie is a way of magically creating lots of Cassandra clusters and keeping track of all of them, because Netflix has, 50 or 60 Cassandra clusters. People heard of a language called Pig? It's a data flow language. It's a kind of a pain to use because it's really hard to debug. Well, it was until we put lipstick on it. So it's lipstick on the pig, see? Which is a phrase in America meaning you made something look extra shiny, right? You got a really old, crappy car and put a really big, shiny, bumper on it or something. It's a real-time visualizer for pig jobs that shows them in runtime as they're flowing, and you can debug. And it's so good that there's a company building a system, a big data system platform called Mortardata, and Mortardata adopted this tool as the visualizer for their platform. So this is effectively now jointly being developed by Netflix and Mortardata, and Mortardata are putting a lot more effort into it because they're trying to sell it for money, and we're happy that it's getting better. Any Clojure programmers here? Come on, we've got to have a Clojure programmer at Aarhus. No one? Oh, all right. Where's David Nolan when you need him? All right. Pigpen is MapReduce written in Clojure that compiles down to pig. I'll show you what it looks like later. I have some code. Semper is Latin for truth, I think, something like that. So S3 is a storage system, and if you write something to it from one place and you read from the other place, eventually you see what was written. Right? But when you've got your big data system writing lots of data over here, and the next step in your processing pipeline's trying to figure out whether it's in sync yet or not, you have to basically delay to wait for the system to become consistent. So Semper is a system for tracking the consistency, and what it does is it delays jobs. It's a listing service that tracks indexes of S3 buckets. It's a little bit geeky, but what it's really doing is papering over the fact that this is a very distributed system. All right, got a few more. If you ever tried to store extremely large graphs in memory, like these movies are related to these other movies in these complicated ways, and there's lots of movies, and you end up with multiple gigabytes of data just trying to store that as a data structure. So S3 Netflix Graph is a very compressed format for storing these types of metadata, highly linked metadata. And Xeno is a system for propagating that kind of metadata around systems. So if you're doing metadata propagation and compression, this is a useful piece of technology. All right, who cares about security here? We got any security? All right, we've got a few more hands. All right, cool. So if you're running security, if you're running on AWS and you run Security Monkey, it's a standalone Python app. It doesn't relate to anything else here. You can just run it on its own. It looks at all of the configuration of your AWS account. In fact, it'll look at multiple AWS accounts, and it'll tell you if anything looks wide open and insecure, like you have security groups set to allow every access, or S3 buckets set to provide too much access. It's a very useful tool. So basically the way Netflix Security Group works is they have the monkey watching over the system. They let the developers do anything they want, and when one of them does something stupid, they get notified and then go talk to that developer and shut it down. Right. So that's the approach. All right. Let's see. This is kind of more like Tim Bray's talk for the next little bit. So Tim Bray was talking about all these bad people out on the internet that are off doing nasty things, right? So the Scumblr is the scum of the internet, and you're sort of searching for them. The idea is that every online brand, there are people trying to break that brand, trying to break into it, trying to set up DOS attacks, harvesting accounts, providing YouTube videos on how to steal Netflix for free, all that kind of stuff. So from Netflix point of view, there's a lot of, the security team deals a lot of things which are actually related to brand management. So what Scumblr does is a search engine. It will go look on Pastebin and Twitter and YouTube and all. It's got plugins for all these different places, even eBay, because people try and sell stuff on eBay that's maybe you don't want to do with your brand. It finds all of those, and then it builds a workflow for people to deal with them. So like, say, a YouTube video that says this is how you steal Netflix and keep getting a new every month, free months forever. So we'll go get a takedown notice, and we send it off to Google to shut down that YouTube video. So that is a workflow that would be attached to a certain type of query, right? So it automates all of that. Now, when you're rummaging around the dark corners of the internet, people lay little traps and bombs for you. So if you go and rummage around and you keep following links to fairly sort of people discussing dodgy things, you'll probably pick up some viruses and other nasty things, and they'll take over your machine. And if they see you always coming from the same IP address, they'll get unhappy, right? They might get even more unhappy. So Sketchy anonymizes the IP address you're coming from and acts as a sandbox so you can't get infected by it. So it's a safe way to go and rummage around in the dark corners of the internet where the Scumblers live and pick out things. And what it does is it gathers screenshots of discussions in chat sessions and products and whatever people are doing and bits of websites and saves them in an S3 bucket for you. So you safely collect all of the evidence you need to go and clean up whatever you're trying to clean up. Right. So these came out a month or two ago. The Netflix security team has finally got enough bandwidth to start open sourcing some of its tools. So does this sound useful? You think? There were a few people in Copenhagen who thought this was useful enough they were going to go off and try and install it pretty much that day. There's a very large-scale intrusion detection system at Netflix that's built using Zool and a bunch of other things. It's called Speed Bump, I think. That one I'm expecting to come out fairly soon. So really, really big. Most intrusion detection systems can't handle the kind of traffic Netflix has and don't understand cloud. So this is an interesting one. All right, so to tie it all together, there's a whole bunch of recipes. There's several recipe apps, but this is basically Google Reader. Remember good old Google Reader used to be your RSS reader, and then they shut it down. Everyone got really unhappy. Well, about the same time, we built a Google Reader replacement using NetflixOSS, it shows you how to glue it all together. And then there's a few other things here. There's a web cryptography. There's a series of standards around web cryptography, and we published a piece of one of those. As this is a series of cryptographic functions that you want to embed in your web browser to perform low-level security protocols. It's not really a standalone thing. And Brutal is a little weird. It's if you use sort of chatbots, it's a system for it's related to sort of think of chat ops or whatever you call it, where you have things that are looking at chat sessions and responding and chatbotting. So it's in that general area. If you're into that space, go look at what it does. I forget the exact details. All right, so that's roughly 40 projects. I'm going to go through the ones, some of them now, and there's one extra one that's not on that list. Okay. So let's look at how we put this together. First of all, you've got to set up some AWS accounts, and Netflix has a particular pattern for doing that, so I'll talk through why we do it that way. I mean, you don't have to copy it, but you understand why we do it that way. Then use Asgard to deploy things and ICE for cost monitoring, so we set up those. You can set up all your security tools. Then you want to automate a build system, set up a service registry, and your black box recorder. Then configuration property system. This is all the foundational pieces you need to run a large-scale thing. Then you're going to put some storage in, so you want to put Cassandra, put all the layering on top of that, the memcached. And then you can deploy some code to it. So you deploy the code by modifying lots of carry-on, creating a whole bunch of forks of carry-on, basically, using Ribbon to chat to them, use Zool to basically mock your APIs as you plug in all the tools underneath them, and then route all the traffic amongst them, and Denominator to route customers via DNS to the particular services. Okay. Then you've got to make sure it stays up, so you're going to run some Simian Army against it and use Hystrix and Turbine to monitor it. And then just to speed up, make developers work a bit better, there's non-blocking logging, garbage collection visualization, building dashboards, and using RxJava. RxJava isn't on that previous list because I think that's also now an external project. Okay. And then you're going to be build your big data. Once you're up and running, you're going to use the big data system to track everything and monitor it. And I forgot Suro. Oops. Anyway. There's another one there. We've got a slide for it. There's a logging pipeline system that you want set up as well. And then some sample apps. And as well as RSS reader, I'll point people at Acme Air and Flux Capacitor. Everyone needs a flux capacitor. So this is the way that we think about setting up Amazon accounts. So you start by building this development test build account. That's a single AWS account. There's no production traffic to it. It's just used to support development, right? The build system delivers code into that account only, right? That's the way Netflix sets it up. So everything that ever runs in production has to run in test first. And then there's a simple command which takes it and it copies the AMI of something that's been tested and puts that into production. And then you auto-scale that and you create, this is sort of cattle versus pets. So you can have pets here, but you always have cattle up here. You always have herds of machines. You never have any individual machines. And you can kill any individual machine in production and it doesn't take the site down. That's the pattern we've got here. Now, the production account has maybe 20 or 30,000 machines in it, and developers all have root to it, and they can do whatever they want to it. But occasionally you've got stuff that has to be audited for security purposes. So there's a separate account which has got a few hundred machines and a much smaller number of developers, and this is for things like SOX compliance and PCI compliance and anything like that. So those are stored in separate accounts, and then traffic is sort of routed between them. But all this information is held here, and you need to be in a different sort of LDAP group or whatever. You need different permissions to get into it. So the backups from these production accounts are all stored into an archive account, and the archive account is an AWS account which only has S3 in it. There's no running code. You put it in a different region. You home the buckets in a different region, so when you copy something to it, it gets copied out of your region. And you can put timeouts on S3, so it gets deleted automatically after 30 days or something like that. Right? Every weekend, you copy from the archive to the test account, which proves that you have backups, and it refreshes the test account with a full copy of all the data that was in production as of last week. So the test account has real data in it. The data from the auditing account, if it's more sensitive, as you do this process, as you do this load up process, you scramble the data, so you tokenize it. So things like credit cards. There are things that look like credit cards in the dev account, but they're scrambled versions of real credit cards. They're tokenized, right? And then the data science account can do daily roll-up sort of ETL loads by also pulling from the archive. There's some continuous streaming data science stuff, but the bulk stuff that's done once a day is done by pulling from the archives. right? So all nicely decoupled. So this is the way it's been working for quite a while. The more up-to-date way of doing it would be to use Docker instead of AMIs, but it's basically the same architecture. You're just generating Docker images and you're spitting them in here, and then once they work, you move them over here or down here. So that's just, you just take seconds instead of minutes, and Docker has some different properties, but most of the work going on, or some of the work going on at Netflix right now is to kind of extend that. And I'd create a separate InfoSec account for running SecurityMonkey, because SecurityMonkey running here can monitor all of these other accounts, right? And so you want your security team probably want their own account to run a few things in. So you sort of separate everything out that way. All right. Anyone here heard of a company called Codespaces? They don't exist anymore. So this is what happened. They built a console. It was like a web hosting company with Subversion repos for the stuff you wanted built, and then customers dropped websites and things like that into Subversion, and then they put it up on a website and they hosted it, right? So what happened was that somebody hacked into the console they'd built that let customers access their accounts, and that console had the top-level keys for their Amazon account in it, right? Just the top level, the ones you get back with all permissions. So that hacker then used that to try and extort money from them. And when they went in and tried to change the passwords on the account, the hacker has the keys. He already created a whole bunch of extra accounts with root permission. So he went in and deleted everything they had, right? And everything they had was in a single account. So it deleted all the EBS volumes, all the instances, all the attached storage, all the S3 buckets that with all their archives. And after a few hours, there was nothing left of the company, nothing at all. So they just shut down. Said, sorry, we're out of business. We have nothing left. All right. So don't do that. Codespaces goes tits up forever. This is a British technical term. After attacker nukes its Amazon hosted data, source sharing site to close following total cloud apocalypse, which is, I think, another technical term. And this is a car off the edge of in a river or something. So not good. How do you not do that? Well, I'd been talking about, this is a slide I'd been using for about 3 years, so obviously the Codespaces people didn't see my presentation. First thing, the top-level account, your security team should have two-factor authentication, and they should be the people who create new top-level accounts, and they should be use the authentication keys, little RSA token things, to do that. So you can't do anything without that. And then what you do is you create delegated minimum privilege accounts, sub-accounts that have things taken away from them, like the ability to delete accounts and delete things and stuff. So if you're creating a console for your customers, you can set it up so that it can only do the things it absolutely has to do and can't do anything else. So you can basically create safe things, and that's IAM, right? Identity and access management. It's a very powerful hierarchical system where you can go and create these things. And then the other thing is to use security groups correctly so that to control who can get where within your system. So let's look at that. So this is how you log into the system, because you've got to be able to log into machines occasionally to rummage around and see why they're not working. So here's a bunch of developers. Here's a Bastion host. So you typically want a pair of Bastion hosts. I've got like this is King's Cross Station in London, and they have platform 9 3/4, and there's a little shopping cart pushed halfway into the wall for all of the people that want to go to Hogwarts. This is the Harry Potter thing anyway. So it's a bastion. You've got to be able to get through this wall. The people go there and take pictures of it, including me, which is why I have a picture of it. So you log into the bastion, and this has a script which basically sudos you to the right user ID to log into any particular machine and logs that you did that, right? So now you have an audit log of somebody to the bastion, and then they logged into the www server and when they did. Now, once you're on one of these, you can't actually log into any because the security groups say that port 22 is only permitted from the bastion, right? The Bastion security group contains however many Bastion machines you have, probably 2 of them, so that one of them can go down and you can use the other one. But that means that that security group means that from the Bastion you can log into anything, but to get to another instance you have to come back to here and come back here. So if you want to copy files from machine to machine, for example, you have to copy them back here, copy them back out. So it enforces an auditable control point. Right. There's not a huge amount of work going on through this. Some people automate scripts that sort of trampoline through here, but you can log all of the what's happening. So there's all stop sign things here. So you can't log in between these. But however, what you want to be able to do is the web server wants to be able to call the stash, which is the data access layer service, and then that wants to be able to call Cassandra. So there's a www security group here on port 80 which lets people connect to it. And there's a stash server, let's say it's on port 7000 or something. And this service will be a member of this security group. The security group is named after the service. And then when you look at this, and there'll be a list of machines here, which all of these services which are allowed to call this service. So you're programming the firewall so you can only get certain types of requests. So the only way you can get into this is from the Bastion of a port 22 or from permitted services on that port. Everything's locked down. Think of this as a really soft, gooey candy bar with hard nuts in it. That's the security model, as opposed to the sort of the hard, crunchy thing with a soft center, which is the way most data centers are built. So if you get through a data center perimeter, you can usually do just about anything. Yeah, maybe layers of security, but individual machines aren't hardened. The way this setup works, individual instances are hardened to minimum privilege. They will only let you do what they're allowed to do. Okay? So it's almost break time, right? Trying to go grab a coffee and come back. So okay, next thing I'm going to do is go through. I've got a slide on each of them individually to dive into a bit more detail, but we're just going to sort of go over the same set. So if you've heard enough, happy for you to come back, go and see some other talk. If you want to dig into each of these in a lot more detail and look at the process required to install all of them, I've got sort of the walkthrough, which is easy, by the way. It's just CloudFormation templates. Then we can look at that. So that's what I'll be doing after the break. So about 20 minutes for coffee, something like that. Through all of the individual projects, sort of one slide at a time. So I mentioned a little bit about SecurityMonkey. What you can see here is this pop-up here, you add a whole list of different Amazon accounts. And then over here, there's a bunch of different ways of searching through things. And here you've got all the different things it found and what sort of level of sort of worriness you should have on them. If you click on one of those, you get this pop-up. So this is the following issues have been raised and need to be fixed or justified. And this is a security group containing 000/0, which means it's wide open to the world. Anybody in the world can connect to this machine, right? Or this security group, whatever is in that security group. So you can justify it if you want to, and then say, okay, it's sort of whitelisted as an okay thing, if you meant to do that. But you have to. But it's got all the rules here, and there's a bunch of stuff. So that's what that does. Anyone that useful? I'm going to run home and implement that. Maybe. Scumblr. So glasses get mixed up with the thing. So it has built-in searches. You put in a search for something that you think would be an interesting search query, and it automatically has built-in APIs for driving Google, Bing, eBay, Pastebin, Twitter, and a few other places, like YouTube, I think was another one. So it will automatically go and continuously search using that query or a set of queries against a lot of different search engine places, and then look for all of this kind of stuff and build a workflow to notify, respond to this so your team can deal with it. And then you can use Sketchy Sketchy is actually a standalone product you can use if you want to go and capture things from dodgy parts of the internet or URLs you don't trust. It actually is useful for that, but Scumblr uses it to drive it. So I think SecurityMonkey, by the way, is Python with Postgres underneath it. Scumblr, I believe, is a Ruby on Rails app. I think Netflix just hired a bunch of engineers recently who randomly use different things, and I forget what Sketchy's written in, but I don't think it's Ruby. I think it's maybe Python as well. Okay. Let's look at the tooling then. So to start with, you're going to want to stand up a whole bunch of services, and it's kind of a pain to have to go to GitHub and compile them and download them and figure out how to build them. So they've all been pre-built. There are pre-built AMIs. You can just go and use the Amazon console to fire them up for Asgard, Aminator, Edda, Eureka, and Simian Army. Simian Army is a single service that is basically a framework for building monkeys. And 3 of the personalities it has are Janitor, Chaos, and Conformity. So these are Java-based monkeys that sit in the Simian Army framework. Peter Sankauskas built all of these AMIs and whatever as a contribution to the Netflix Cloud Prize that I was running last year. Now, you don't just need an AMI, you have to configure them correctly. You have to have the right security groups and a few other bits and pieces. So the other thing that Peter did was put CloudFormation templates around that. So that's all of the information, metadata information you need to launch an AMI. So that makes it really easy. And we're just going to do a walkthrough for Asgard. And you'd repeat this for different accounts, and you'd repeat this for other tools too. So there's a URL to these templates. You do git clone blah 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 to get it. They're all written using Ansible. You create the stack. You read it on there. So basically, you click create a new stack. Oops, where is it? Push this button. You click create a new stack. You create a stack. You give it a name, Asgard. You upload a template file. You browse, and you get the Asgard JSON that was provided from Git. Right? Very simple. And then you have to give it your IP address so that that machine has permissions for you to connect to it, but nobody else. So that's a secure way of starting up an instance that lets you browse to it. So you need to give it an IP address that's either the gateway or your own machine. What the from would look like. And a key pair name, an instance type to do it on. And then you say continue. You don't need to set up any tags. And then you confirm. And then you sit back and wait, and these little yellow dots turn into little green dots eventually, and everything gets created, and all the resources get created. And a minute or two later, you have a running instance. Now, one of the things that this instance has is a public DNS name here, right? So this is what your browser will browse to find it. So you have to cut that out, just cut and paste it out of there, stick it in the browser, and there is Asgard. This is the first startup. So that's it. There's no build. You just go and run through that template. 2 or 3 minutes after you started, you have a running copy of Asgard. Now, Asgard manages your Amazon account, so you need to use you need to give it an access key and a secret key and the account number and all that stuff. Remember to use IAM to do, take some permissions away from your thing. Don't put your top level Amazon account in there. Create some sub accounts. Next thing is, once you've done that, this is the standard console for Asgard. So you've got a bunch of icons here for creating things. You want to create a database. RDS is up here. There's SimpleDB. There's EC2 and auto-scale groups and AMIs and all the different bits and pieces. And this scales. They use this tool to manage accounts with 10,000 plus machines in it. So when you say, show me all the instances, it's kind of slow, but it doesn't fall over, right? It's got some, actually, if it gets to be big, it's got a little button that says, do you want to populate the search term? You click that button, otherwise, just to save it. So this is what all the developers use at Netflix for deploying things. When you're actually working with it, this is the normal thing you'd be doing. You've got to deploy some code. You fire it up for the cluster called Obi-Wan, which is the name of an application. And you see these 2 things. This is the previous version of the application, and there are instances here, but they're out of service. And there's version 64, which is in service. And if you wanted to shut this down and switch back because there was a problem, you'd hit enable here, and you'd hit disable here. Then all of the traffic would go to this version. Right? So it's like continuous versions, red-black push. That's what this automates, and it's something that the Amazon console doesn't really do a good job of automating. When you want to start version 65, you go find the AMI that Aminator built for you that contains the new version of the code. You say what instance type you want to start it on, how many you want for the autoscale group. Click that button, it'll fire up. When they're all up and running, you can connect to one directly if you want to just check it's okay. Once it looks like it's working, you enable it, then you disable the old one, and then you have to delete this one because it only allows 3 versions, right? Just a rolling set. You got one back and one forward and one in the middle. That's really all you need. So the last 4 years, this is how Netflix has been provisioned, except nowadays it's actually, this is manual provisioning now. There's automated provisioning that pushes things in. But anyway, quite a few people using this. It's one of the most popular Netflix open source projects. All right, so that's the first thing you want. Next thing you want to know is how much you spent. So this is the cost tracking. There's all kinds of slice and dice stuff up here, and you can get, you can see on-demand, reserved, all those kinds of things. This is different applications firing up and coming and going and auto scaling and whatever. So it's a extremely powerful tool. It's better in some ways than some of the commercial projects that are out there. And it actually predates some of them in terms of when we started building it. Problem is it includes high charts, and you can't deploy the license terms for high charts say that you can't do a pre-built AMI because you have to have a license. So you have to go through a build process for it, unless eventually we'll take high charts out and put something else in. And if you care enough about that, then you could help because this is open source, right? But high charts is free for non-commercial use, so it's actually fairly cheap. It doesn't cost much to buy a license for it, and you may already have one because it's a nice graphing package. So that's the next thing. You also want to build, you want to automate your build pipeline. So on GitHub, there's this nice tool called CloudBees. It's a service, which is Jenkins as a service. So it's a build automation system as a service. One of the nice things about CloudBees is that any open source project, they will build it for free. Normally you have to pay them and have an account, but if you have an open source account on GitHub, you can configure CloudBees to just do builds for you. So whenever you contribute code or whenever you do anything on your open source project, CloudBees will just do all the builds for you, and they generate your code, and you can then go and stick it in an AMI. So unless you want to run your own Jenkins server, CloudBees is probably a good place to run one as any. So once you've done the build with Jenkins, you've got a bunch of code that you want to deploy. Use a bakery for that. So this is conceptually similar to what Docker does. You've got a base image. There's a base AMI, which is basically a build of a Linux machine. This will actually work for other things, but then you do a snapshot on it, and you build a volume. And then you take the code and you put it on from the package, and you build all these bits and pieces together. And it basically, it mounts it, it cheroots to it, it does all of the installations, all the RPMs or whatever you've got. And then it basically snapshots and turns that into an AMI with some API calls to AWS. So what comes out of it is an application AMI that includes all your code pre-baked in. Now, the nice thing with Docker is you can actually see the layers. And after you've built it, it's like a series of translucent layers that has metadata. This is all built in, but you can go look at the base. So think of it as a prototype for what ended up as being Docker. Now, Eureka is the service registry. So here's an entry in it. You've got a name of the service. You've got a few instances running it, different versions of it, that are in different places. Some of them in US East, some in US East. There are 2 different zones in US East. And it tells you that all 4 of them are up and gives you the clickable links. You can go look at them. So basically, the idea here is that you ask for services by name, and it says, well, these are all the ones I can find, and they're all in these locations. And the key thing here is that it tells you what the AMI is, so you know what version it is, what instance it is, what zone it's in. So you can do zone-aware routing. You can go to the one that's in the same zone that you're in, because that's lower latency and a little more highly available. It also gives the IP address, URLs, and ports, keeps track of the things like, it's not just DNS, it's got other things in it, like where is the health check, where is the status URL, all of those kinds of things. And it tells you this life cycle. It says, I'm healthy, I'm unhealthy, but I'm still here, and I'm initializing. Don't send me traffic yet. I've come up, I'm here, but I'm not ready to take traffic. So you can have services, instances which are out of traffic. And that's also very hard to do with some of the similar kinds of tools. So there's an AMI and a CloudFormation template, same process for launching Asgard. It's trivial to set up. You want one of these in each zone, so let's look at that. So here's the typical way you'd want to run this is 3 availability zones, A, B, C. You run a Eureka server. They talk to each other to replicate their data. So if an application here registers with this Eureka server, it will be discovered across all 3 of them, right? It gets copied sideways. So there's 2 calls. There's a call that says, I'm here, register. And then there's renew. We call renew every 30 seconds. So this thing, if you don't call renew, it'll basically put you in an unhealthy state. So people will know not to try and call you. And then cancel. And then there's get registry. So everyone else is basically doing get registry and finding out that this application service is here. So clients and servers are both the same, really, but in terms of Eureka. But this one here did get registry, discovered this service here, and can call it. Yeah. So that's basically how it works. Hopefully that makes some kind of sense. Like I say, you can build things like this with Zookeeper or Console or etc.d. The problem then is that if you get a partition, let's say this network here gets lost, then you don't actually know if this one here died or whether this one side died. But if you get a partition, both sides will keep running. If you're into CAP theorem, this is a AP system. It's available when it's partitioned. And since the services that are in here are mostly just registering with their local system and most of the calls happen within a zone, it actually keeps working quite nicely because you only really need consistency within a region, within a zone. And eventually, if the partition mends, it will send traffic back and forth and get itself back in sync. If you delete all 3 of these machines, and Chaos Monkey does kill individual ones, and to test it, sometimes you kill all 3, everything keeps working. There's a cached copy of all the data in all the apps, and it doesn't throw it away, because you learned not to do that after you've had one outage. And then when you fire these back up again, they don't populate the world with an empty registry, because that happened, that caused another outage. There's many things, and then you can lose a third of them, and it basically understands that losing a third of your instances is actually something that might happen, so it's sort of okay. But if you lose more than a third, it goes, hang on a minute, something might be broken. So the code here has everything that ever happened at Netflix has been fixed in it. It is an incredibly robust piece of software. It's not terribly sort of architecturally tidy because it's one of the first things we wrote, but it's very robust. Okay, I was talking about that black box EDA service. So EDA is think of it as a timestamp delta cache. You've got AWS, and every entity on AWS you can say, give me a list of all the instances, give me a list of all of the whatever the things are, and then you can get a describe call against all of them, and you get back a big JSON object that describes that thing, right? So what EDA does is it walks just walks these things continuously, sort of scraping your Amazon account at a fairly standard rate. And every time it gets one of these JSON objects, it looks in its database to see if it already had it. If it had it already and it matches, then it does nothing. If it's different, then it stores the new data in the database with a timestamp, and the old data is still there with a different timestamp. So now you've just got this delta cache of every JSON object that ever came back that describes your cloud. It just harvests the whole thing. It doesn't get too big. This is just JSON. There's 2 versions of this, 2 implementations. One uses MongoDB, which is reasonably well compressed. The other one uses Elasticsearch. I forget which one, whether the Elasticsearch one was developed later, and I'm not sure if it's got updated in the thing, but both options are there. So that's the Amazon information. But then you've got Eureka with all this information about these are the versions of the services that I'm running and all their metadata. Well, that's a JSON object too. So EDA pulls from Eureka the complete set of what's there. And when it changes, it does the same thing. So now you don't just have a black box for what Amazon did, you have a black box for everything your application did. And at any point in time, you can say which version of everything, what was the state of the universe at any point in time, going back to when you started Edda. And yeah, it's amazing how useful that is. And if you ever play around, if you get used to it and then it's not there, you go, this is insane. You know, why wouldn't you know that? You can also feed your own custom state in it. If you've got other services or other frameworks that you want to monitor that have similar kinds of characteristics, you can go out and suck data from them. Like if you're running on say, Eucalyptus or OpenStack in your own data center, you can actually pull the state of the underlying Eucalyptus services or OpenStack services that are under the hood, you know, the physical hardware and the state of the actual switches and, you know, machines that you wouldn't normally be able to see on AWS, and you can suck that in. And now you can actually start correlating this switch failed, which took out these networks, which caused this partition. So whenever you're in an incident review, you know, the week after something went wrong and somebody says, what was the IP address of that machine again? You don't know because it changed, right? It's not there anymore. So this is what the query syntax looks like. The monkeys all talk to this, but you can generate it yourself. It's just a REST API. So this says, this is an IP address since the dawn of time. Get me them. And it says, these are the 3 instances that have ever had that IP address. Right? Very simple. And here's one saying, I want the difference limit to of this security group. So this says there's 2 security group versions here at 2 different times, and this is a difference of the JSON, right? In this case, you can see it change from 10.3 to 10.4, the plus and a minus here, right? So very powerful. So what the security monkey is doing is queries like this, looking for anything changed, and then notifying you that there's a /0 or something bad in there. And what, anyway, it's incredibly useful. And it's not, again, it's a standalone project. It's written in Scala. It has no other dependencies across the Netflix tools, so you can fire it up without using the rest of the architecture. So if you're running AWS, there's no reason not to have that. AWS themselves have a logging capability for the APIs that are used to configure it, and you can actually get an archive now, but they only added this, I think, within the last year, that you can actually get a complete archive of the state of AWS, but that doesn't give you a state of your application. And it's not all correlated, and it has about a 5-minute, 10-minute delay. So this is a little bit more up to date. Okay, properties. You want to set a fast property to turn on a feature. You want to do it, or set a URL. Let's see, you want to use S3 buckets for an application. You want to set it up so in Europe it uses buckets that are in Europe, and you have a different S3 path in the US, so you want that to resolve to the US. The code's the same, everything else about the app's the same AMI, right? But you want to have them behave differently in different regions. So you've got overrides here. So this change, and then it's got this nice impact view. It impacts 2 instances, and it's got this zone and this app, and it changes this value to something or other. We're creating a new fast property here, and you can select it and skip it. Anyway, exactly what the property is. It's a stack of configurations. You've got your container configuration, your library configurations, your application properties, your persisted database, and then the runtime configuration, and they all hook into here. There's a little database behind this that we use SimpleDB or DynamoDB. And to do multi-region with very high availability, Netflix uses a Cassandra-based version of that, but multi-region Cassandra is a bit more than most people need. Okay. Data storage. So RDS, that works fine. Asgard, you just push the buttons, you get a cluster, it's very easy. DynamoDB, we don't actually have support for that, but it gives you a nice scalable way to get started with a database in the cloud. And then Cassandra lets you go beyond that. It lets you run your own services and give you something a bit like DynamoDB, but with very large scale and with multi-region support. It's very important, particularly for large-scale distributed systems. The storage model for Cassandra has immutable backups in it. So basically, whenever Cassandra writes to disk, it always writes a very large immutable file sequentially, which is great for solid-state disks. Always run Cassandra on solid-state disks. Don't even think about running it on boring bits of spinning Rust. You'll be much happier that way. Just about everybody that ever had a bad experience with Cassandra was trying to make it run on spinning Rust. It's just not worth it. All the happy people are running on SSD. Because it's doing large immutable writes, you can pick them up and copy them to S3 and do your backups. And that's Priam does that for you. So here's Priam. It runs alongside Cassandra. It starts it up. It's fully distributed. It uses the data store underneath, SimpleDB or whatever, to coordinate itself so that everybody claims a different key token. So if you start a collection of nodes, they will form themselves into a Cassandra cluster by claiming all the right tokens to do that. It's completely automated. S3 for backups and recovery. So you can tell Priam, I want to restore this Cassandra to a point in time, and it will go and pull in all of the S3 data, all the archive files from S3 up to that point in time and get you as close as it can. It gives you a REST interface to Priam that actually is hooked up to the underlying metrics within Cassandra, so it gives you a way to collect those that's a bit cleaner. All right. Client from Asternax client. So this is a very efficient, nice client for using Java, for accessing Cassandra from Java, rather than the sort of slicing and dicing text strings, select blah, blah, blah kind of stuff. It basically uses a Fluent API natively to generate it, so it's very efficient. There's no text handling. There's no messing about with converting things to and from and slicing and dicing. So it's a very clean API. It's a little bit like, if you've used Apache Spark or something like that. This got this API where you just keep adding thing.thing.thing.thing. It's got nice retries. It's token aware. I was in the talk earlier about React. React, when you make a request, you make the request to an arbitrary node in the cluster, and it's usually the wrong one, and then it has to go sideways to find the actual data. So there's 2 hops to get data. Once your cluster gets any size at all, you're very unlikely to guess correctly. This is a client that's token aware. It knows the topology of the ring, and so it knows exactly when you're making a request exactly which node to go to, and it'll go directly there. So it's a single hop, and that saves a network. You've only got one network transit instead of 2. It's also aware of the cluster, so it'll call the node that's in the same zone as you. So it's lower latency, usually sub-millisecond to make a call within zone, usually a handful of milliseconds to go cross zone. And it's got all these recipes. This is some of the recipes. So if you wanted to do a distributed row lock or a multi-region lock or have a uniqueness constraint, or this one's actually one of the best ones, chunked in multi-threaded large file storage. If you go to a big distributed cluster or database and say, I want to write a gigabyte of data to it, most of them will fall over. Because when you try and write a gigabyte, it times out because you can't write that much data in any reasonable amount of time. And whichever machine you actually hit will blow up because it runs out of RAM. And when you try and read it back, you'll have the same problem. What this does is it takes it, chunks it into usually 256 kilobyte chunks or whatever the nice chunk size is, and sprinkles them over the entire ring. So it'll take an arbitrary large file and completely evenly spread it, and then multi-thread all the reads and writes. So it writes in parallel to as many nodes as you have. And you can, if you want to write a bigger file or you want to write bigger and bigger things quicker and quicker, you just make your ring bigger. Put more, the more Cassandra nodes in the cluster, the bigger thing you can write and the more faster you can write it. It just happens faster. Very nice tool, very nice thing. So S3 has an option to do something similar. If you ever need to store big things in S3. The reverse index search is sort of a tricky thing, and then there's a high cardinality reverse index as well. They're kind of getting around some of the problems that you have when you've got a distributed data store. And then the all rows query and message queue. It's just like there are naive ways of doing this which tend to blow up and make people really unhappy. And we had enough developers trying to do these problems over and over again to just, okay, let's make a pattern. No, don't do it that way. Here's the standard way of doing it. And it's very easy that way. Okay. So EV-cache, this is memcached. So there's a bunch of memcached. And you've got a client, and the client wants to write some data. So instead of writing to one memcached, it writes to 3, because you want 1 in each zone. And then when another client wants to come in and read, it sees the new data. So if you've got something that's like a session cache, you've got a series of web requests that form a session for a customer, and you want to remember something for a few minutes, you use this pattern. So you store it in your memcache, and then it comes back in the others. It's doesn't guarantee that all the writes complete. Like I said, it's the eccentric volatile cache, and it's ephemeral. And yeah, but it works really well, and it ties into Eureka to find and locate everything, and then it'll actually, you can have multiple memcaches in each zone as well. So it'll scale up. Netflix has some ridiculous amount of, some huge number of terabytes of memcached running. All right, so we need to route customers to code. So remember I said at the beginning you were going to have an architecture that looks like this. Here's all your Cassandras with Priam. Here's all your microservices. These are the Amazon regional load balancers, the ELBs. But your customers, this is East Coast, this is West Coast US. You've got to connect them. So you have route DNS to route them, and you've got 3 different options within this environment. And Denominator is the library that gives you a single API which can talk to any of these, and you can actually switch back and forth between them quite cleanly. And these have ridiculously bad APIs. Route 53 is quite nice. This one is SOAP or XML RPC. That's your 2 choices. This one is REST, and it's worse than this. This is the worst REST interface anyone has ever encountered. There was an email from Adrian Cole that wrote this, and he was listing what he had to go through to get this thing to produce something, and the last step was pull the forks back out of your eyes. It was just that bad. Won't go into it anymore, but we can have a long rant about bad DNS APIs if you want. So if something goes wrong, the other thing we have is Zul, the API router. So behind these load balancers is a layer of API proxies. They have a tunnel which connects across here. So if some traffic lands in this region and you go like, you know what, that customer, we just saw them in this region, and for some reason we really just, maybe they flew out to California, but they're usually in the East Coast. Just to kind of keep them consistent, because the guy's wife is, or spouse is still here playing Netflix, and they're playing Netflix, and they want to keep the account roughly a little bit more coherent. They're going to route them through this pipe, and just a few people. So if people that are misrouted, you just route them back and forth. So the Zul pipe here can actually call instances over here, and vice versa. But none of the instances here can see any of the instances here. So there's no other direct calls going on. So you've got one layer at the top that can route requests back and forth, and you've got a layer underneath that moves data back and forth, and it's an incredibly clean architecture. This is very, very scalable, very clean, very architecturally nice. And we had a lot of arguments about how this would work, but in the end, this did work well. So if something goes wrong, let's say Amazon decides that they're shutting down a whole zone because a aircraft landed on it, or a hurricane hit it or something, or a generator blew up. The system just keeps working. That's basically a no-op. Right? There will be no errors anywhere. There might be sort of 20 or 30 seconds of a few timeouts here where customers retry over to here, and that's it. It's designed to do that. In fact, there's a chaos gorilla at Netflix who takes out a whole zone, because bigger than a monkey. Monkeys take out an instance, a gorilla takes out a whole zone, and they run it once a quarter in production, and it uses a random, it actually uses Python random call to choose which zone is going to kill every time they run it. So you don't know in advance which of the 3 is going to be killed. They get everyone in a room when they're about to do it, right? But it picks one at random. And every now and again it finds something that's snuck in. So if you lose a whole region though, it's kind of a bit more difficult. So half the customers are still completely happy because they're routed this way. So what you want to do is shut down this load balancer and send all the traffic this way. And that's a relatively manual operation. So there's Chaos Kong, right? Really, really big gorilla, King Kong, that does this too. And they've actually run Chaos Kong. They do actually a planned thing where they just route everything over to here and run the entire of Netflix out of one zone, out of east, and then they run it all out of west. So it's normally running 50-50, but every now and again they prove that they can switch all the traffic over. They do it in a more controlled fashion. They don't actually kill everything. And if you lose a DNS vendor, let's say Ultra DNS blew up one day and it was being used for something, you can just switch to one of the other vendors. All of the data, these APIs are so bad that you can't actually read back what you wrote, right? It should be a basic property of an API is the ability to, if you put data in, you should be able to get it back. That don't work like that. So Denominator maintains a complete set of state outside the APIs, which it can apply to any vendor. So you can actually take the state that Denominator's managing and push it into a different DNS vendor and make it work. So one of the reasons for going with these two vendors is that they had a feature that Route 53 did not have, which is the ability to route traffic by state geographically. So about 3 or 4 months ago, Route 53 added that feature. I now see no reason to use these vendors whatsoever. Really, we spent 6 months filing bugs against these two, and this stuff just worked. I think Amazon Route 53 is probably just going to clean up the DNS world as far as I can see. It actually works. You can automate against it. So all of this large-scale distributed systems automation you'd like to do actually works reliably. It's amazing. But it's amazing how bad the others are actually, rather than how good Route 53 is. They just finally caught up with all the features that we needed. Anyway, so the Zool layer. This is what it looks like. You've got a HTTP request coming in. There's all Zool servlet. There's a filter runner. Then there's a bunch of groovy filters, groovy language. So these are little functional groovy plugins that just do one step, and it's a completely functional environment. You just stack together these little plugins, the filters. That's the pre-routing filters that you can use to transform your URLs or whatever you feel like. You can do security in here, like you can do your OAuth authentication or whatever you feel like. Check your cookies are good. Look up the incoming IP address. Do a DOS attack filtering for somebody that's scraping your site. That's what you can put here. Then there's a routing filter, which could actually decide not to route anything, or it can route it to whichever layer you want behind. So based on what type of request it is, it can pick which service to send it to. And then on the way back, once you get a request coming back, it can be post-routing, so it can be filtered on the way out. So this is a response, and you can rewrite the response to look the way the outside wants it to look. These are all dynamically loadable, so there's a filter publisher, persistence, poller. It takes about 30 seconds to update these groovy filters, and it's all completely programmable. And there's quite sophisticated tooling in there. This is a reasonably efficient system. It's in use. It's in front of everything else. And one of the things that Netflix had was that the web server part of Netflix kept getting bigger and bigger and fatter, and after a few years, it just had too much stuff in it. But it has a single entry point that everyone expects to see. So what they did was they put this in front of the entry, in front of it. So what you're actually talking to now is the proxy. And behind that proxy, it actually routes different pieces of the website to different underlying services. So we're able to start breaking up that web server in a horizontal way so that there's a server now for a different page in the website, right? But it still looks like one integrated front end because you're still hitting that front end. This service is not restarted very often. It's a very long-term persistent service, and it sits just behind the Amazon ELB. And then all of the dynamic traffic is behind it, right? Make sense? Any questions on that?
Yeah. One question. How does that work together with EDA? Because this is all routing that happens in configuration you're pushing that is not translated into AWS configuration. Does EDA query this as well?
I don't know, actually. We did have we had a prototype in EDA of that was collecting the routing information through the site. There's separate systems that are actually collecting all the routes that are going through. But I think EDA, you'd fill it up too quickly because the individual routes change too much. The logging data for tracking routes just fills up a big Hive data store, and whereas EDA is more slowly changing stuff generally about the state of the system. So it's more, think of EDA as the sort of the dynamically changing configuration rather than the traffic flow. Traffic flow is a much higher level thing. We'll get to that, I think. So this is the ribbon library. You come into the front end, you go to an edge service, and you want to call one of the middle tier services. So you come into the client within your code base. This is a Tomcat server. You have your ribbon client, which is basically HTTP client, and it calls a bunch of, it'll talk to this zone ABC. If it's just a regular load balancer, it's just round robining across the 3 machines. And this one is coming in and it's saying this is zone aware, so it knows whether it should be turned to go zone A or zone B. You see? You can control it. It's got a bunch of different options. And then you're using the Eureka service to populate the information in here about where all these machines are. Okay. This is a very boring and slow GIF which automatically updates to show you something or other about it. So I'm just going to skip this. So Carrion's the server container. It's got all this lifecycle management in it. It's service registry, property management. It's got hooks for the latency monkey. Latency monkey injects delays and errors into the system to simulate errors. And then it pre-configures. It has a status page and a health check. So almost all of the services at Netflix started out as this. And then you just add your own code in the back end to it, of it. The status page console has all the JMX. It has all of the jars that you were built with, so you can introspect the exact version of all of the code that's in the system at runtime. And that's useful. And it has all the Eureka information as well, and the current state of all of the configuration variables that were set using Pythias. And the sample one just says hello world, and when you send it, it just says hello, right? That's all it does, as usual, right? It's the biggest, most complicated way to say hello world with megabytes of Java code. All right. Chaos Monkey, Simian Army. So you can use the Chaos Monkey to hit your system. There's also a Janitor Monkey, which works against the editor history to find unused Amazon entities, which it then deletes and tidies up after a time delay. So it's when Asgard runs, it's creating new order scalar groups and things like that, and it tends to leave stuff behind. So Janitor Monkey sort of works alongside that to keep everything tidy. Then Conformity Monkey. So remember I said that we have status pages, and those status pages can be discovered using Eureka, and they can be logged in EDA. The Conformity Monkey, you can have rules. So think of this like find bugs at runtime. Like you can put a rule in your build system that says this version of this jar should never run, should never be built with because it's known broken. And then you can add that same rule to Conformity Monkey to say everyone in production who's running that needs to stop, right? So you could use this if you've got a security alert, you want to track who's got round to updating against the latest blah, heartbleed or whatever bash thing, blug, right? If you want to impose a version level, you can use this and it will just run continuously and it will send people annoying emails until they stop running the wrong thing again, right? Hystrix, I think we had someone here that was playing around with Hystrix. So you have a service coming in, and then it has all these dependencies. So this is a service, and these are all the jars it was built with, and each of those has dependencies on lots of services. When a service fails, it tends to block this dependency and break it, and you don't want to take out your whole system because of that. So what you want to do is wrap this in a circuit breaker that says, if this dependency is broken, I'm going to wrap this library that's used to talk to it in a future and wrap it in its own little thread pool, and if anything goes wrong, I can just ignore it and stop calling it, and it's very unlikely to sort of take over all my threads and break everything else. So it's got a nice simple state diagram for doing that. Do we walk through? Okay, it's getting late in the afternoon for this. You come in here and you go through, and if the circuit's open, everything's fine, and you run it, and everything's happy, and you come back here, and if it's broken, you basically, if you're short-circuiting it, you just return immediately and you get a fallback. And then there's a thing here that says you're too slow, and you report latency errors and calculate the health, and then you flay this thing. So if the system is too slow for too long or too broken for too long, it'll flip the circuit breaker, like overloading a circuit, electrical circuit, and then somebody has to push the switch every now and again to see if it's got better. And that's the basic pattern here. This is what Hystrix implements. This is, once you have Hystrix in your service, it exposes on an extra port a WebSockets interface. You connect your browser to it, no other things in between, and you get a window that looks like this. Your browser downloads some JSON from it and builds out this whole dashboard that is changing continuously. So it's a WebSocket. So it's a long-lived connection. You've got JSON pumping into your browser, and it's continuously updating this thing. I know what it was built with, something D3 or something like that. You can see this is a large number of dependencies that the API server has, and the circle tells you how much traffic there is relatively. And we haven't got, none of these fail, but they go red, and this stuff gets failed, and these percentages go to 99%. I don't have that on this particular slide. So, very nice system. Hystrix, Turbine aggregates across multiple servers to give you an aggregated view, because if you've got 100 machines all running these circuit breakers, you want to get an aggregated view of them. So Turbine sort of hooks it all together for you. All right, these developer things. Blitz4j, like I mentioned, better handling of log messages. It will drop messages during a storm rather than killing your logging system or killing your service, which Log4j will happily do for you. Again, this is one of the ones where after repeated outages at Netflix, we've built something that wouldn't break, right? It's one of those ones, right? It's not particularly clean or nice. It's just like we had to do this because logging kept killing the service. And then this garbage collection visualization, this takes huge log files of garbage collection and shows you what's going on and visualizes it. And I can't really read all these things, but yeah. Like I said, there's very few people in the world that really understand garbage collection. So this is Pytheas. This is the dashboard building tool. So uses Juice and Jersey and FreeMarket and jQuery and data tables and D3, jQuery UI and Bootstrap, right? It puts that all in one big bundle. So you download this, and then it says there's some instructions that says go to this bit and like edit a few lines of code in here, and then you add another few lines of code in here and a few lines of code in here, and stand back, and then an enormously sophisticated display appears for you. It's just, it does all of the scaffolding to build the whole thing together is done. So think of this as a scaffolding that contains all of these entities. Is that the right way of talking about it? I don't know. Maybe using the wrong terminology, but this is a dashboard we use to monitor Cassandra. So these are Cassandra clusters. There's a 6-node cluster. Here's a large number of nodes cluster, and you can't really see one here, but these. If a node was offline, it would go a different color, and you can mouse over this to see all the individual nodes and what's going on. So we're trying to Cassandra clusters, generally visualized as rings. So that's just one of the ones we built. RxJava. The best thing here is go back to last year's GOTO Aarhus and watch Ben Christensen's presentation, because that's much, you get a whole 50 minutes of everything to do with this. The key thing I think about RxJava is that it simplifies concurrency for the people trying to write the code. And this observable layer is a very nice abstraction. So the problem here is that you come into a service and you've got all these microservices. I have to call 10 or 20 or 50 services to get my response, and I don't know what order to call them in, and I need to do it in parallel, and I could multi-thread it or have callbacks or that. I'm just going to declare them all to be observable, and then I'm just going to map them together, right? And this layer basically automatically deals with it and hides the implementation. So underneath that observable, any one dependency could be built as a cache return. It could block. It could use multiple threads. It could be non-blocking I/O. It can do anything it wants. But all you see is an observable, and it's a very clean interface for writing, for assembling, data in. Sort of a very nice functional programming kind of model. All right, big data bit. I guess we didn't have that many people here that care about this. But if you're running Hadoop clusters, Amazon makes it trivial to start Hadoop clusters by just calling the Elastic MapReduce service. And so Netflix ended up with a large number of them and then needed a tool to kind of wrangle them back into a manageable place. So this is a service for managing large numbers of Hadoop clusters that has two sides. There's an admin side that you use for provisioning clusters. And then there's an end user side where you basically submit a job to the cluster, and it finds a cluster that's got capacity and the right data and goes and processes it. If you're running lots of Hadoop, you want to monitor the behavior of it. This is a tool that was announced last Thursday night, I think. Yeah, because I had to update my slides from Friday morning to include it. So this is what's this called? Swim lane diagram of the different nodes or tasks that are being attempted and different things happening. This is a like a plot showing all the different behaviors in the system. And you get a list of all of the jobs, and you can click on a job and drill in and get all this stuff. So it's a fairly nice way to monitor large numbers of Hadoop jobs. Semper S3 updates take a while to propagate, so you want to track state. This uses DynamoDB to build an index cache of the eventual consistency of S3. DynamoDB has calls which enforce consistency, but including the delay, so you can use the consistency model of DynamoDB to actually make sure your S3 works well. And then it tracks on it graphs how many of these updates are inconsistent or delayed. That's what Lipstick looks like. This is a visualization of a pig pipeline. And this is Pigpen. Look, some code. I'm at a developer conference. I've had some code in here. Dave Nolan isn't here to tell you what he thinks of this. Anyway, so some closure code. So this is MapReduce. This is word count, which is the standard MapReduce thing everyone does. And you can do two things with this code. You can run it locally in your laptop in Clojure to prove that your logic is correct on a little sample program. Once you've got that logic correct, then you compile this using Pigpen, and what you get is actually a pig program which you run on a Hadoop cluster. It's not actually in Clojure anymore, right? But it translates this Clojure thing that you can do rapid development and prototyping on your laptop and get the analytics the way you want it, and then you can spit that out and run it on a fully distributed large-scale calculation. So it's quite a nice tool. All right, putting it all together, and then we'll wrap up. This is the RSS reader application. So you have your clients. They connect into the Edge service. It's built out of Carrion. It uses Blitz for logging. It's got a Eureka client, so it tells Eureka, hey, I'm here. And it discovers that there's a backend service, so it can call that. So it uses Hystrix to call there. And it generates logs. Blitz4j generates logs, so they all come in here. Carrion's managing them. There we are. So this is registering itself into here. And then at the back end, it has a bunch of RSS publishers, and it has a Cassandra cluster. So if you have Asternax client, and you have the Ribbon client, and then Servo to monitor metrics. So it pulls together a fair amount of the system. So that's, you can just fork this and play with it and use it as a starting point, or you can use it as an RSS reader if you're really desperate. It has no authentication or multi-user capabilities, so that's what you get. So the next one is flux capacitor. The flux capacitor is very, very complicated and doesn't really do anything, because that's what real flux capacitors do. It's got all of these different tools from Netflix, plus it integrates Graphite, Jersey, Jetty, Netty, and some Tomcat stuff. So it's a much more complete, because it's including, there's no graphing tools in the Netflix environment currently, because the thing they built internally is too big and complicated to open source, and they haven't got around to it yet. But if you want to use Graphite for graphing, it's built in here. This was all built by Chris Fregley, who used to work at Netflix, and he learned how to do all this stuff, and then he left, and he's been working as a consultant and bouncing around different places. So he just built this as a sort of a demo app, and also to try and help himself get work. So if you want to hire a Netflix guru, Chris Fregley's kicking around. Then IBM came by and said, hey, this stuff looks interesting. We want to figure out how to do cloud native. And we went, really? You're IBM. And then they said, yeah, really, really, it's interesting. So we had a whole bunch of people from IBM come by, and they really did figure out how to use it, and they became probably the most sophisticated user of the NetflixOSS currently. And what they've been doing, the first thing they did was they built an example app. Well, they took an example app they'd built as a WebSphere demo called Acme Air that was just a standalone WebSphere app, and they rebuilt it using NetflixOSS. So there's a Hystrix, it's got Asgard, it's got, I forget what that is, that's probably Eureka or Edda or something. They had all the bits and pieces running, and you could go and schedule flights on this imaginary airline. And they won a prize in the Netflix open source project contest because they were the best new example app. And there's a bunch of engineers here. Probably, I'm not sure if it's quite public yet, but the engineer that built this has apparently left IBM, and I'm not quite sure where he's turning up, but I think he's moving to the Bay Area. I think we've probably just stopped there. I don't think he's quite admitted where he's going to go. Anyway, so yet again, open source projects work for hiring. This is the current version of the page as of last week. So a few companies that are using a NetflixOSS. Yelp are using Asgard. Hotels.com are using Zool. Suncorp are using quite a lot of it. There's a few companies that aren't on here. Nike's been using a lot of NetflixOSS recently for the back end for all their Internet of Things. You know, people literally running around the world generating data, has to go somewhere, and they're looking at using the sort of cassette Netflix model for that. Okay. So you can use NetflixOSS to scale your startup or to reinvent your enterprise. And this was at the reInvent conference, so a little pun there. And you can add existing projects or start your own. So there are a few projects around NetflixOSS that were spawned up by other people now. And this is what the team looks like, most of them anyway. And that's my last slide. So, any questions? Or okay, I've got some more stickers here. So if anybody feels sufficiently inspired that they want to take away a sticker, put it on their laptop and promise to install something. That look useful? Yep. Oh, you want the sticker? Sure. Which tool will you download? Which one? Oh, the dashboard, Hystrix? Oh, Pytheas, yes. Pytheas, good. Yeah. All right. Anyone else? Any other questions?
There were two questions that were asked including the application. One is,
Oh yeah, I forgot to mention the application.
what is RDD? Probably just missed the explanation.
RDD. Oh, RDS, probably?
It says RDD. I don't know whether anybody wants to press up asking the question.
Well, RDS is the relational database service that is MySQL, and you can fire that up on AWS. RDD is a graphing thing, like it's for doing plots, but I didn't think I mentioned that today. So.
Last question. Is there any noticeable performance penalty using SQL instead of the API directly? Sorry, you know what? I'm looking at the wrong talk. That's why the questions don't make sense.
Okay.
Give me a second.
Random questions.
That was the deep dive into
We
big data.
deep dive into big data. I shall answer questions on that. Yes, of course there is a overhead. No, I don't know what the answer is.
I have a question about Asgard.
Yeah?
Is it suitable for, so at our company we do a lot of different projects, right? Is it suitable for that as well, for deployment for many different applications, or would you have one for just one application?
So if you're putting, typically there's an instance of Asgard for each AWS account.
Okay.
Right, so depending on how you slice up your AWS accounts, you would have that number of Asgard. So because it's really designed to tell you everything about an AWS account, everything that's in it, right? And then it does have some user authentication, so you could actually control who gets into it and some things like that. But that's pretty much how it's used. So Netflix splits concerns using accounts. So the data science team has their own account with their own copy of Asgard, and test has its own copy of Asgard, and production has its own copy, and the people doing the secure audited stuff have their own copy.
Okay, but there's nothing stopping you from deploying several different kinds of applications and so on?
Well, it's, there's hundreds of different applications running in the account. Yeah, each group uses it. So there's probably 500 engineers using Asgard, lots of different teams. There's actually multiple applications in there. So for example, the customer service team have their own set of applications which are really totally separate from everyone else, and they just find their apps. Asgard records the owner of every app. So you have an email address for everything, so that you can call PagerDuty when it breaks and wake them up at night. Right. So that's an important thing. In fact, you could set up Chaos Monkey to say that if an application doesn't have an owner, then it shouldn't be running in production, so it'll just keep killing it. So if you try and launch an app with no owner, it would just keep killing it until you admitted that you were the owner. And we discussed doing that. I don't think anyone ever really did that, but you can, as a mental model, I think that's useful. Yeah?
Are each team or each service is deployed through Asgard probably, but the data layer or the Cassandra layer, is it also going that way, or is it more general infrastructure?
Yeah, Cassandra's a little different. The Cassandra servers are deployed using Asgard. You deploy them, you have to deploy each zone separately. So you have to use Asgard 3 times to deploy separate order scale groups because you don't want Amazon rebalancing across zones because the data is specific. So it's a little different to deploy. It's trivial to create in test, anybody can create a Cassandra cluster. Yeah, I've created Cassandra clusters. I did it live on stage once as a demo. I actually had a Jenkins job create 2 Cassandra clusters and benchmark them during my talk and in a 1-hour presentation. We started the cluster, we ran benchmarks, we doubled the size of both clusters, and then shut them down and looked at the results within an hour. I had 48 nodes running at the end of that. So anyone can do that. Now in production, the way Netflix has it, there's a team that looks after Cassandra, and that's because there's real data in there, and you want to make sure that it's being a bit more carefully managed. And then the other thing is that the version of Cassandra keeps changing, and they're managing that version. So the version of the code of Cassandra is sort of a separate concern from the data that's in it. So every team has its own Cassandra cluster with its own data in it, but the Cassandra team updates your Cassandra cluster for you and puts new versions of Cassandra in underneath. So you don't have to worry about the version of Cassandra you're running, you just worry about your data. So there's a little bit of a cross-cutting setup there. And the way Cassandra nodes run, they are Amazon instances, the same as everything else, with onboard disk. The disk is inside it, and it has solid-state disk, and they're on a 10 gigabit network. So when they die, when a node gets killed, it gets replaced by a new node, and then the data gets sucked in automatically and replaced, and then the thing keeps going. So it's sort of a bit like remirroring a broken mirror on a disk subsystem, except it's data between nodes. Sort of resolvers it. And it's a 3-way version. There's I've done a lot of presentations that go into a lot more detail about how Cassandra works, but the nice thing is you have 3 copies of the data a copy of the data in each zone, and then you have multiple copies in each region. So, and then there's no internal mirroring, and the disks are really cheap because they're inside the instances. There's no attached storage to worry about. There's no contention in the storage subsystem. And you get the lowest possible latency because the machine has got the disk in it. And solid-state disk reads from a local disk are very, very fast. So that's my favorite way to run storage nowadays. There's all these marketing terms like converged storage and hyper-converged storage. Have you heard those? If you've been dealing with storage tier, operations people do. I have what's called vapor-converged storage, which is I put it in the cloud and I don't need any storage people anymore. So the administrator for a Cassandra system is a Java distributed systems developer, and there's no storage people involved. That's it. Like the entire storage team goes away. All those backup and SAN engineers and all those people, yeah, they don't have any of those at Netflix anymore. We have some developers, and that's it. So, yeah, the storage people don't like hearing that story.
You coined the term no-ops, didn't you?
I didn't coin the term no-ops, no. Somebody from Forrester did, but I commented on the blog post, hey, that sounds like what Netflix does. And then everyone got very upset. And it's, yeah. But then people said, stop using that, you're making people grumpy. But it's kind of, I was trying to explain what it was like to not have an operations department or an operations team, but still run, a large-scale distributed system. What's left of the ops team at Netflix reports into development, and it's a site reliability engineering team that owns the incident life cycle. So they build tools to detect that something's gone wrong, call the developers to change their code in production, because the ops team doesn't touch code in production. Well, there is no ops team. Developers operate their own code in production. They're entirely responsible for the state of their app. And you say their code is done, your coding is done when you've removed your code from production, right? Because there's this thing, oh, you're not done until it's running in production. In this case, you're not done until it's no longer running in production. Because if some of your code is running in production, you're on call, so you're not done. Like if you can delete it from production and it's not running anymore, then you can go. Or if you can make somebody else responsible for it, then you can leave, right? Go on vacation, something like that. So that's the way it works. So the incident lifecycle for the site reliability engineering team, they own the availability metric, how many nines or whatever the uptime is, and they own detecting that something's gone wrong, organizing the response, getting people on a call, and then they schedule the incident review at the end of it and make sure that actions are taken on it. And that's their responsibility. And it's very different to a typical ops team or sysadmin team. They also work with the other NOC kind of environments, because Netflix works with the Xbox, Microsoft Xbox NOC, or the PlayStation NOC or whatever, because every now and again, Sony decides to update all the PlayStations in the world with some push thing, and it might break, and then Netflix starts getting calls because the PlayStations are broken, and whatever. So all those kinds of coordinations happen. Or occasionally we push a bug that breaks Xbox only or something, and we call them and say, hey, we've broken you, sorry. Those kinds of things. So it's an interesting team, but it's got a very different focus. Everything else is an API that goes down into AWS or out into a SaaS vendor like PagerDuty. Right, that's the model. Any more questions? Right. I'm around all day tomorrow if you want to chat about something, or you think that there are gaps in this set of packages. This is probably 2/3 of what Netflix built internally. There's a whole pile more stuff that they are going to open source one day. They haven't got around to. So you have to keep watching the blog. All right, well, thanks very much, everyone.